Hey everyone, welcome to what is most likely your first homework video of seventh grade math. Few quick things before we get started. You are not required to watch these videos in general. There might be one or two times in the year when I ask you to, but in general, if you can do these homeworks without using the videos, that's fine. Like these are a resource for people who need them, not a requirement. Secondly, you might notice that I'm going to do this assignment, Desmos Practice 7.1.01 or seventh grade Unit 1, Lesson 1 in the book. That doesn't necessarily mean you're supposed to do it in the book. Some years I assign things online on the Desmos website. Sometimes, some years I assign them in the book. You need to know which one I've assigned you depending on what year you're watching this video. If you're not sure, go to Google Classroom. It'll say on there on the assignment post, do it online or do these pages in the book. So it doesn't matter. The questions are the same either way. If you look at this in the book or you go to Desmos online, the questions are the same either way, okay? Um, and lastly, please try to use these videos as a resource to boost your learning and not just a way to copy the answers. I know you could just pause and tune me out and copy the answers, but that's not going to help your learning if you choose to do it that way, and it'll affect your performance on the quizzes that you'll eventually have to do this stuff on, okay? So the first question says, you got this original portrait here. Describe how these copies that this person got are different or the same. And so we don't have to write anything too in depth for each one. I would say the image A here is too tall. It's not a scaled copy, right? It's stretched up and down. Image B does look like a scaled copy to me. Is scaled. Let me use a different color for each one. Is scaled. Saying scaled is the same as saying it's a scale copy or a scale drawing, um, but smaller, which is fine. Scale copies can be bigger or smaller than their original as long as they maintain the same shape is the biggest thing, right? Or the shape is preserved, as we like to say. Image C, it looks like has been slanted, you might say. The angles, the interior angles, as we call them here, have been changed. You can't change interior angles. You can't slant things to make a scale copy. And so um, that's what I'll write here. For this one, I'll say it's slanted and the angles have changed. When we make scale copies, can't change the angles. And the last one, image D, looks like it's stretched on the width, right? It's too wide. All right, let's keep it moving. Uh, Here we're supposed to identify, like if this A right here is our original figure or original drawing, whatever, which of these four are scale copies? Just by looking at them, it looks to me like figure one and figure four look to be about the same shape as the original, this one just being smaller and this one being bigger. I can immediately eliminate figure two. It's obviously an angle has been changed. It's got a weird slant to it. It's not going to be figure two. Figure three looks similar, um, but let's check it mathematically. The original figure, if you go to the bottom of the A and count to the top of the A, straight up, not diagonal along the A itself, but just straight up, top to bottom, it's two boxes right here. If I do the same thing to figure three, it's three boxes. Okay, so it's a little bit taller. It's 1.5 times as tall because 2 times 1.5 is 3. Okay, well then, in order for things to be to scale or proportional, as we say, then the width of figure 3 also needs to be 1.5 times the width of the original figure. When I count the width of the original figure, it's also two wide from, the bottom of the A. But figure 3 is also two boxes wide. That doesn't make sense. If they made figure 3 taller, but then they didn't also make it a little bit wider to go with that, then it's stretched up and down. It's too tall. And so I'm going to eliminate um, figure 3 for that. We could check figure 1 and figure 4. We know that the original figure is too tall and too wide. And so any figure that also looks like an A like that, that is the same height as it is width. Like if it's 3 tall and 3 wide, that's good. If it's 4 tall and 4 wide, that's good. Because it maintains that same ratio proportions, right? Same height to same width. And so if you look at figure one, it is 1 tall and 1 wide. That's proportional to 2 tall and 2 wide. When I say two, I'm talking about the number two. And if you look at figure four, it is 4 units tall and it is 4 units wide. That's proportional to the original 2 by 2 because they just doubled everything, right? So we're going to go with figure one and figure four being our good scaled copies there. And it says, how does each scaled copy compare to the original? Okay, well, figure one is half tall and wide. I'm using shorthand here. I appreciate it if you write in more full sentences, but I'm just trying to keep the video short. Figure one is half as tall and half as wide as the original figure is what I mean. Okay, and then figure four, on the other hand, they went the opposite way. They made it bigger. They made it twice as tall and twice as wide. Oh, lost my book. All right. And the last question here is, how do you know a figure is not a scaled copy? You'll see that sometimes on these videos, I like to leave some questions that I didn't answer so I can see your thinking on them. And so I think I'm going to leave that one up to you to come up with your answer for, okay? I'm going to move on to questions 5 and 6 with these Tetris piece looking things. And it's telling us that all three of these figures are scaled copies of each other. So we know that as fact. And we're supposed to just figure out their perimeters and their areas and describe any patterns we see. So the perimeter is when you count around the outside. So I'm going to do perimeter in black. Perimeter of figure one would be 1, 2, 3, 4, 5, 6, 7, 8. Each time I went around the box is one. Oh, it's literally already there. Okay. And then the area of figure one is going to be you count the boxes themselves. Like it'd be 1 box, 2 boxes, 3 boxes. And so that's where they're getting this 8 and this 3. And so let's do the same thing for figure two. Instead of me marking each little individual box like that, though, I'm going to speed it up by just marking this whole thing as 4 boxes wide, 2 boxes tall, 2 boxes on this little section, 2 boxes on this little section, 2 more boxes on this little section, and 4 boxes tall right here. Now, if we add all those up all around, we'll have the perimeter of figure two. 4 plus 4 is 8, 10, 12, 14, 16. So the perimeter of figure two is 16. Rather than doing the area of figure two right now, I'm going to go and do the perimeter of figure three real quick. Across the bottom here, if you count it, is 8 squares or 8 units. 4 right here, 4 right here, 4, 4, and it is 8 tall. And hopefully you notice that each of those is just double what we had in figure two. 4 went to 8, all these 2s went to 4s, and also this 4 went to 8. So each number doubled. That means the total should double. Like I could count these up, or I could notice a pattern and say, oh, 8 doubled to 16. So I'm writing times 2 here, and 16 is going to double to 32. And you can check it, add those up. They'll be 32. Okay, now let's look at areas, and I'll switch to brown. One, I'm just going to put a little mark in each one as I count it to help myself keep track. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so the area of figure two is 12. And that's a lot of boxes to count up there, but I'll just do it real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, this row is going to have 8 more. So if I count this row, that should make 24, 32. I'm just counting by my 8s. 40, 48. And so what I notice here is that the pattern is times 4. 3 times 4 is 12. 12 times 4 is 8. Um, there's a reason for that, and we'll get to a lesson that's specifically around why the perimeter goes up times 2, but the area goes up times 4. But for now, just describe the patterns and maybe make a guess as to why do you think that is? Why is it when the perimeter goes up 2, the the area gets scaled by a factor of 4, we would say. All right, and lastly, we got a little bit of spiral review. I'm going to do half of these and leave the other half for you to do. The tougher ones are the ones where the answer in the box is going to be a fraction. So for example, um, something times 12 makes 3. Well, I like to think of it this way. I know that 3 times 4 equals 12, and I could reverse that by saying 12 divided by 4 equals 3. But I got to do it with times. 12 divided by 4 equals 3. Something times 12 equals 3. I got to think of a fraction that does the same thing as dividing by 4. That's going to be by 1/4. 1/4 times 12, or 1/4 of 12 equals 3. Um, so same thing here. 21 times something equals 7. Well, I know if I did 21 divided by 3, that would equal 7. So let me just turn that dividing by 3 into a fraction. Instead of dividing by 3, I want to times by 1/3. So all these actually, you could figure out by just dividing the two numbers. Like if I'm not sure what I multiply 6 by to get 9, go grab your calculator and go do 9 divided by 6. And you should have a calculator button right in the Desmos you're working in right now, right? 9 divided by 6. If you do that, it's going to show you either as a fraction, it might show you 3/2, or as a decimal, it might show you 1.5, depending on the setting you have set on Desmos right now. Either one of those are good answers, though. You can put either one of those in the box. I'll put 1.5, okay? And so I'll leave the other 3 for you to complete, and I'll see you next time.